I want you to picture a scenario. It's Tuesday afternoon. You've been staring at your terminal for about 4 hours. You're building this really slick AI agent. Let's say it's a market research bot. It's supposed to go out, scrape a few financial news sites, read quarterly reports, crunch the numbers, and then, fingers crossed, write a nice, clean summary for you.
Sounds like a pretty standard workflow. I mean, that's the kind of thing everyone is trying to build right now.
Exactly. But here's the reality of building it. The scraping step. That takes 3 minutes because the sites are slow. The reading and parsing step. Another 2 minutes, easy, because the PDFs are huge. Then the analysis, you're looking at maybe a 6 or 7 minute runtime for the whole chain.
I think I know where this is going. You hit run, you go grab a coffee, you come back.
And there it is.
Yeah.
Red text. Just everywhere. An error message. And it's not in the scraping. It's not in the parsing. It's in the very last step. The summary generator choked on, like a malformed string or a timeout.
Oh, that's the heartbreak moment.
It is heartbreaking. Because to fix that one tiny line of code in that final step, you have to restart the entire process. You lose the scrape data, you lose the parsed text, you have to wait another 7 minutes just to see if your fix even worked. It is the absolute worst part of AI engineering. It's the black box problem.
It's a complete productivity killer. And honestly, looking at it from a product management perspective, that is exactly where velocity dies. If your developers are spending 90% of their day waiting for progress bars just to debug a typo, you aren't shipping features. You're just burning compute credits.
Well, hold on to your hats, because I think the Gradio team just solved this. Or at least they've given us a massive upgrade in how we fight it. We are diving deep into a new library called Daggr.
Daggr. Right. It dropped just recently, February 2nd, 2026. And looking at the documentation, the architecture, this feels different. It's not just another build an agent framework. It feels more like a fundamental shift in how we visualize and debug these workflows.
It really is.
Yeah.
So today the mission is simple. We're going to unpack what Daggr is, why it's completely different from those clunky drag-and-drop tools you might have used, and how it turns your messy Python scripts into inspectable AI workflows.
Inspectable is the key word there. We need to be able to see inside the machine. But before we get into the nuts and bolts, let's just set the stage. What is the core promise here?
The headline is this. You write Python code, just normal readable Python defining your workflow. And Daggr automatically generates an interactive visual graph from that code. It's not a separate design tool. The visual is derived directly from your code.
Okay, that distinction is massive. Because usually in this space, you have two very separate camps. You've got the no-code camp, where you're just dragging boxes around on a canvas to build a flow.
Which is great for explaining things to stakeholders, but it's terrible for actual engineering.
Right. Have you ever tried to version control a drag-and-drop canvas? You end up with this massive, unreadable JSON file. You can't look at a diff in Git and see what actually changed. It's a black box in a different way.
Exactly. I don't want to code in a browser window dragging wires around. I want to code in my IDE. But then the pure code camp has its own problems. You have total control, but you lose all the visual context. You can't see the data flowing. You're just staring at logs.
So Daggr is attempting to bridge that gap, code-first visualization.
Precisely. You define nodes, you define connections, all in Python. But then it renders this beautiful interface where you can see every single step as a directed graph. Inputs, outputs, intermediate states, it's all laid out for you.
So effectively, the visual layer is for verification and inspection, not for construction. You build with the rigor of code, but you debug with the clarity of a diagram.
That's the perfect way to put it.
Yeah.
And the way you construct this graph is surprisingly elegant. They haven't overcomplicated it with 100 different classes or anything. They've boiled it down to 3 primary node types. I really want to get into the weeds on these because they show you how flexible the system is.
Okay, let's break them down. What's the first building block?
First up, we have the GradioNode. And this is where the pedigree matters. Since this is from the Gradio team, they know that the ecosystem is already full of thousands of little Gradio apps.
Right. If you're browsing Hugging Face spaces, almost every cool demo you see, whether it's image generation or text classification, is probably running on Gradio.
Exactly. So the GradioNode lets you take those existing apps, either ones you built or even apps hosted by other people, and just treat them as a single block in your workflow.
Wait. So I can take someone else's hosted demo and just plug it into my pipeline?
Yes. You don't have to copy-paste their code. You don't have to figure out their dependencies. You just point the GradioNode at their endpoint, and suddenly their output becomes your input.
That is incredibly smart. It promotes reuse in a way we haven't really seen before. Instead of rewriting a specific image upscaler for my project, I can just find one that works on Spaces and plug it in like a Lego brick.
It's the ultimate lazy developer move, which, means it's brilliant. There was actually a great reaction from the community mentioned in the release. Sebastian Buzdugan said, "Mixing endpoints and Gradio is such a smart combination," and he's spot on. It turns the entire Hugging Face ecosystem into a library of functions you can just call.
It creates a sort of microservices architecture, but without the headache of managing the servers yourself. But let's be real, the world is messy. Data formats never match. You can't just plug node A into node B perfectly every time.
Oh, absolutely not. The retriever outputs JSON, but the summarizer wants a string. Or the image generator wants a specific aspect ratio that the previous step didn't provide.
And this is where low-code tools usually break down. If they don't have a specific JSON parser block, you're just stuck.
Enter the second node type, the FnNode. This is your Swiss Army knife. It wraps arbitrary Python functions.
The glue logic.
The glue logic. The unsexy stuff that we spend 80% of our time writing. With the end node, you just write a quick Python function to clean that list, or reformat that string, or filter out the bad results. You wrap it in an M node, drop it in the graph, and the pipes connect.
And this is why the code-first approach wins, because you have the full power of Python available in that node. You are not limited by the menu options of a GUI builder. If you can write it in Python, you can put it in the graph.
Exactly. And finally, we have the heavy hitter, the third type, the inference node.
I'm assuming this is for the big models.
Right. This is for when you want to call Llama 3 or Mistral or Stable Diffusion via an API. It interfaces directly with Hugging Face inference providers.
So it handles the API keys, the headers, all that connection protocol stuff.
It abstracts all of that. You don't have to write the adapter code. You just say, I want this model, and the inference node handles the conversation.
So, quick recap. GradioNode for reusing existing tools, FnNode for your custom logic and glue code, and InferenceNode for the heavy AI lifting. That pretty much covers the entire stack.
It does. But here's the thing. Having nodes is nice. Building a graph is fun. But that's not why I'm obsessed with this tool. I'm obsessed because of what happens when things go wrong.
We're back to my favorite topic, catastrophic failure.
We are. Remember my scenario, market research bot.
Yeah.
Minute 7, step 4 fails. In the old world, I cry and restart. Daggr solves this with what I think is its absolute killer feature, state persistence.
Okay, let's unpack this carefully. State persistence can mean a lot of things. What does it mean for a developer who's just trying to ship a product?
It means Daggr automatically saves, everything. It saves the structure of your workflow. But more importantly, it saves the cached results of every single node, the input values you used, and even the layout of the canvas. It stores all this locally on your machine.
So if your pipeline crashes at step 4, step 1, 2, and 3 are effectively frozen in time.
Yes, they're cached. You open up the Daggr interface and you see the graph. Step 1 is green success. Step 2 is green. Step 3 is green. Step 4 is just blinking red.
And usually you'd have to go back to the grid, fix the error, and rerun from the very top.
Not with Daggr. This is the magic. You can click on step 4. You can see exactly what input it received from step 3. You can see the error message. And then, and this is the part that blows my mind, you can modify the input just for that node right inside the visual interface.
You can hot patch the data midstream.
You can hot patch it. Let's say step 3 produced a string that had some weird characters in it, and that's why step 4 crashed. You can manually delete those characters in the Daggr inspector, hit run on only step 4, and see if the logic holds.
That is massive. That turns debugging from a compile and wait cycle into an interactive conversation with your code.
Exactly. You don't have to re-scrape the internet. You don't have to reparse the PDFs. You just iterate on the failing step until it works.
That changes the velocity completely. You're not waiting 7 minutes for a retry. You're waiting, 2 seconds?
It's like having a save point in a video game right before the boss battle. You can keep trying to beat the boss without playing the whole level over and over again.
And from a product standpoint, that ability to inspect the intermediate state is gold. Because often the pipeline doesn't crash, right? It just produces garbage.
The dreaded hallucination.
Exactly. The output looks vaguely correct, but the numbers are all wrong. In a black box system, you have no idea where the error crept in. Did the scraper miss the data? Did the summarizer just make it up?
You're just guessing. You're changing random prompts, hoping it fixes it.
With Daggr, you can click through the history Okay, retrieval output, correct.
Yeah.
Parsing output, correct. Look at the prompt generation node. That's where I got confused. You can pinpoint the quality drop immediately.
It brings visibility to the hidden layers of your application. And because it allows for this independent inspection, you can compare implementations. You can swap out step 3 for a completely different function, run just that node, and compare the outputs side by side without touching the rest of the flow.
I want to circle back to the code first aspect because as a product manager, I care a lot about how teams collaborate. We touched on this earlier with the Git issue, but I want to emphasize why this is so much better than the GUI-based tools for a team environment.
You mean the whole reviewability factor?
Exactly. If you send me a pull request and it includes a massive XML file from some drag and drop tool, I just have to trust you. I can't read it. I can't see what logic you changed.
But with Daggr, since it's just Python,
I can read the diff. I can see, oh, you changed the temperature parameter on the inference node from 0.7 to 0.5, or you add a new filter in this end node. The code is the documentation.
it respects the developer's workflow. It doesn't try to force me into a walled garden where I have to use their editor and their file format. It's just python.pip install Dagg.
Speaking of installation, how does this fit into the broader working environment? Is it strictly a local thing?
It's incredibly flexible. It's open source, available on PyPI. You can install it with pip or UV if you're running Python 3.10 or newer. And the integration is seamless. You run it locally, and it just serves the canvas in your browser.
And I read that it leverages Gradio's tunneling features as well.
Yeah. This is super cool for demos. If I'm building this agent on my laptop and I want to show you the progress, I can just generate a public link standard Gradio style, and you can open the canvas on your machine.
That solves the whole "it works on my machine" problem, or at least it lets me see that it works on your machine.
Exactly. You can click through the nodes, inspect the outputs, and see exactly what I'm building. And if we want to make it semi-permanent, we can deploy the whole thing to Hugging Face spaces. You just add Daggr as a dependency.
So your development tool can actually live in the cloud if you need it to. That's very versatile.
It is. But, and there is a but here.
There's always a but.
I know we're hyping this up, and rightfully so, but we need to be realistic. This is a brand new tool.
I did notice the beta labels everywhere.
Giant neon experimental signs. The team is very, very clear about this. The API might change. Things might break.
So if I'm a CTO, I shouldn't be rewriting my entire banking infrastructure to run on Daggr just yet.
Definitely not. It is explicitly a development and prototyping tool. It is for inspecting and experimenting. It is not a production runtime engine. You wouldn't use this to serve millions of requests per second.
And what about that state persistence we were just loving so much? The local caching?
That comes with a warning, too.
Yeah.
Since it's all stored locally, updates to the library could result in data loss. If you update Dagg to a new version, your saved cache states might just vanish.
So don't treat it as a database, treat it as a scratch pad.
Exactly. It's a workbench, not the factory floor. You use it to design the engine, tune the timing, and fix the leaks. Once you know exactly how the logic works, you might export that into a more hardened script for production.
That makes sense. It's about using the right tool for the right phase of development.
You know, taking a step back, looking at the bigger picture here, we're seeing a lot of movement in the agent space right now. Everyone is trying to figure out how to chain these LLMs together reliably.
It feels like we're moving past the chatbot era, one prompt, one answer, into the workflow era.
Precisely. It's not just about the model anymore. It's about the system. It's about the tools, the functions, the logic that connects them all. And tools like Daggr are acknowledging that complexity. They're admitting that these systems are prone to failure and hard to understand.
That's a really insightful point. Instead of trying to hide that complexity behind a slick magic button that says, "Make me an agent," they are exposing it. They are saying, here is the graph, here are the nodes, it's going to break, and here's how you inspect it.
It's empowering. It respects the intelligence of the builder. It brings the rigor of software engineering, things like debugging, inspection, version control, to the messy, chaotic world of AI experimentation.
And that combination, the flexibility of code plus the clarity of visuals, that's really where I think the magic happens. It stops being a black box and starts being an engineered system.
It raises an interesting question for me, though. If tools like Daggr succeed, if we get better at bridging this gap between coding the logic and visualizing the flow.
Where are you going with this?
Well, think about the traditional software lifecycle. You draw a diagram on a whiteboard, that's the spec.
Yeah.
Then you go write code, that's the implementation. And they never, ever match.
Never. The code drifts away from the diagram within the first hour.
But with Daggr, the code generates the diagram. The implementation is the spec. The map is the territory.
That is a fascinating thought.
Yeah.
If the distinction between a technical spec and a working prototype just disappears, we might be looking at a totally new paradigm for programming these complex systems. You're not just writing instructions, you're sculpting the flow.
A paradigm where I spend less time staring at a blinking cursor and more time actually building cool stuff. I'm in.
Me too. But for now, I'd settle for just not losing my data when step 4 fails.
Amen to that. If you want to check it out, Daggr is available now on pypi.pip. Install Daggr, give it a spin, break some nodes, and let us know what you build.
And remember, it's beta, so back up your code.
Always. Thanks for listening, everyone.
Catch you in the next deep dive.